Today I'm going to go over the homework for targets 4 and 5, which is our graphing the cube root functions, finding their domain, range, and zeros. The first thing we need to be able to recognize is why it's a cube root function, because that's not always going to be told to you in words. So remember, if we have that 1/3 exponent, or if we have that 3 inside of the root, that tells us that it has to be a cube root function. When we graph cube root functions, we're always going to start with the table of our parent function, and then we're going to apply our transformations. So remember, our parent function, we have the x values -8, -1, 0, 1, and 8. We use these values because they are all perfect cubes. So when I take the cube root of them, I'm going to have all whole numbers and not have to worry about any decimals or having to plug it into my calculator. Then I'm going to apply the transformations given to us in the equation. So the +3 in the equation, remember that tells me I'm moving left 3. We always think the opposite of anything in the parentheses or underneath the root. It's the opposite, and it's always to your x. To move x values left 3, I have to subtract 3 from them. So I'm going to subtract 3. I get -11, -4, -3, -2, and a +5. Anything outside of the parentheses or outside of the root is always going to affect your vertical. So the +1 tells me my graph is moving up 1. So to my y values, I want to add 1 to everything. So I get -1, 0, 1, 2, 3. So we're going to go ahead and graph those. Even though -11, -1 doesn't fit on your graph, I'd always recommend estimating a point out there to help you with this shape. Then we have a point at -4, 0, -3, 1, -2, 2, and 5, 3. Connect it. Make sure it is a curvy graph because our cube roots are always curvy. The domain, or our x values, talks about our graph going left and right. It goes to the left and to the right forever. So our domain is all real numbers, and our domain will always be all real numbers for cube roots. Our range, my graph's going up to the right and down to the left. It will always do this forever. So we will again have a range of all real numbers. Our zeros, remember we said those are our x-intercepts. I can see on this graph my x-intercept is at -4, 0. For b, we're going to do the same thing. I'm going to start with that parent function table. So we have -8, -1, 0, 1, and 8, -2, -1, 0, 1, and 2. Horizontal shift, then, I want to look underneath my root. I have a +4, so that tells me I'm going to the left 4. So I'm going to subtract 4 from all of my x values. Subtracting 4, I get -12, -5, -4, -3, and a +4. To my y values then, on the outside of that root, I have +2, telling me I'm moving up 2, so I'm going to add 2 to all those y values. So I get 0, 1, 2, 3, and 4. So we'll go to graph this. Again, I'm going to estimate that -12, 0 spot. I know that was on my x-axis, so I also know that's going to be my 0 at -12, 0. And at -5, I'm at 1, -4, 2, -3, 3, and then last but not least, at 4, we are at 4. Connect your dots, keep your arrows on the end. I have a domain there, left to right, of all real numbers, and a range of all real numbers. Okay, when we flip it over to the backside, we're not doing targets 4 and 5 again, but we're reviewing target 3, solving our radical equations. So remember when we solve these, we always want to isolate that root. So on this first one, I need to get the square root of x over 6 by itself. So the first thing I'm going to do is subtract 3 from both sides. So I have 8 equals 2 times the square root of x over 6. Divide both sides by 2, and 4 equals the square root of x over 6. To get rid of a square root, remember we square it, so we'll square both sides. So we have 16 equals x over 6. And then I need to get that x by itself, so I'm going to multiply to get that 6 out of the denominator. So I'm going to multiply both sides by 6. So 6 times 16 is 96. So x equals 96. Check your answer by plugging it in. 96 divided by 6, so I'm plugging in 96 for the x up here. 96 divided by 6 is 16. Square root of 16 is 4. So then I'm doing 2 times 4, which is 8, and 8 plus 3 gives me 11. On number 4 here, our square root is already isolated, so I'm just going to go ahead and I'm going to square both sides. So 9 equals 12x minus 1. Adding 1 to both sides, 10 equals 12x, and then divide both sides by 12. We can simplify 10 twelfths to 5 sixths, so I have x equals 5 sixths. On number 5 here, we do need to isolate first. So the first thing I'm going to do is add 2. So I have 3 equals the square root of 25x. My square root is isolated, so I square both sides to get rid of that. So 9 equals 25x. Divide both sides by 25, and x equals 9 25ths. Again, make sure you take these answers and you plug them in, make sure they work. This one will end up getting 1 on both sides, so I know 9 25ths is a solution for that. If you need help checking your answers, please come in to go over it. So number 6, start off by subtracting 1 so that square root can be by itself on this side. So 5x minus 4 equals 4. Square both sides to get rid of that square root. And I have 5x minus 4 equals 4 squared is 16. We'll add 4 to both sides. So 5x equals 20. And then divide both sides by 5. So x equals 4. Again, plug that into your equation. I know 4 times 12 is 48. 48 minus 1 is going to give me 47. Sorry, I am plugging that into number 4. Sorry, plug that into number 6 and your numbers will be better. So I have the square root of 5 times 4 minus 4. 5 times 4 is 20. 20 minus 4 is 16. The square root of 16 is 4 plus 1 gives us 5, so we know that 4 does work. Please come in and ask any questions that you have remaining.